Hello everyone, welcome back. This will be the second video under this sections. Remember, we're still on functions, and for this video we'll be talking about hyperbola, right? So yeah, let's get started. Just to go back, in grade 10, this is the form that we used, or this is what our hyperbolas looked like, right? And you had q, right, which we will talk about soon, and we had a, which we will also talk about very soon. And yeah, so like I was saying in the previous video, something you should always remember is that there are certain things that will have the same meaning throughout, with functions like q, for examples. Q can be defined as different things depending on the functions we are talking about, but then there is then that one thing that q will always be in all the functions. Like for example, I will start with it here. By q, it's still the vertical shift, right? Vertical shift. Yeah, so like the upwards movement and the downwards movement, that will be q, right? Yes, so yeah. And then as for a, here's the thing. A determines the shape of your hyperbola. Like a tells you the shape of a hyperbola. And for a, the thing is, there are many rules, ne? There'll be so many rules. Like if a is greater than 0, then if a is, greater than 1, or if a is between 0 and 1, and so forth and so forth and so forth. But I don't want you to focus there. That's not necessarily that much important, right? Yeah, it is important, but not necessarily, right? You could still get 100% in math without having all that. What's really important is for you to know that if your a is positive, right? So of course I should write here that a determines the shape of your hyperbola. And by that, if your a is positive, I'll say a greater than 0, you're gonna have a graph like this, a hyperbola looking like this. You have this, and you have another hyperbola like this, right? And of course, this is just assuming that q is equals to 0 here. We will come to that as well. The yeah so yeah so you realize that if your a is positive, then your hyperbola, one section will be on the first quadrant, the other will be on the third quadrant, just like this. And something I noticed, which is very interesting, is that when you just draw a straight line, your straight lines become a positive, straight lines. By that I mean, with an increase in x values, the y values also increases, right? If you draw like a mini Cartesian plane here, you will realize that as the x values increases, the y values also, they do increases, right? Yeah. Let's move on. And also now, if your a is negative, right? If your a is negative, you'll have one in the second, one in the third, and also you draw a straight line cutting through both of them. You realize it's a decreasing line. Well, when for an increase in x values, the y values decreases, and as y values increases, the x values decreases, right? Yeah, and of course this is just assuming that also q is equals to 0. So now this q, what is it? Yes, we know it's the vertical shift in it, but what is q specifically for a hyperbola? Then you realize that, oh, q, it is a horizontal horizontal shit, no, asymptote, asymptote, right? It's your horizontal asymptote. And an asymptote, by definition, it's a line that your graph will approach, but it will never touch. You see that line? Yeah, the line that your graph will approach but never touch, that will be the asymptote. And now this is me addressing the q being equals to 0. If q is equals to 0, remember q at the same time it is the y value, right? Y value. It's the y value. Q is the y value. So yeah, if q is 0, we mean that the y value is 0. Now the question is, where on our Cartesian plane is the y value 0? So we draw, a mini Cartesian plane here, y-axis, x-axis, and the question we ask, where on the Cartesian plane is y equals to 0? It's that point is on your x-axis, straight on your x-axis. So this line here, on your x-axis, this is where our y will be 0. And therefore when you draw your thing, your hyperbola, you find out that your hyperbolas will never cross the x-axis. It'll either be something like this or like this. It will not at all cross or even touch the x-axis. It will approach but not touch, and by definition that is an asymptote, right? Yeah. Yeah. I think we can move on, right? We can move on. Just wanted to show you guys something here. In this case where a is 0, maybe, yeah, so a is 0, right, and q is 0. So in that case we're gonna have our graphs like this. Oh no. We're gonna have our graphs like this. They're gonna be like this, right? But now as soon as this thing it's greater than 0, say maybe it's equals to 1, right? If q is equals to 1, then we know that the shift has happened where we moved from 0 to 1. So now we'll be here, right? I'll go back. This is the x-axis, this is the y-axis, and this is the shift to where y equals to 1. And now when we draw our what do we call this, our hyperbola, it's gonna be something like this. It's gonna be something like this. You can see even here we were able to cross the x-axis, but one line we were never able to cross or even touch was this red one, because it's the asymptote. We will never touch it, we will just approach it. You understand? Yeah. And in terms of the shape also, if you're having just like here, if maybe let me remove this. Here we have what we have, q being smaller than 0, implying that we shifted 1 unit downwards. So it's gonna be something like this. There's gonna be this downward shift, and then our graphs will be just something like this, right? So this is just like just to give you an idea of what a hyperbola is. But I'm confident, I know from grade 10 we did a lot of hyperbola, and we still have in mind what hyperbola looks like, right? Yeah. So, and like now I was saying that a hyperbola, if a is positive, it will be on the first and the third quadrant. If it's negative, it will be on the second and fourth quadrant, right? I also want to say that now you can see here, coming to the grade 11 materials, we have a new member, we have p, right? And that p, it's okay, we'll talk about a p. But what I was saying with the quadrants is that you would realize that with now, as we include p in, p is the horizontal shift. Yeah, p is the horizontal shift. I'm gonna write it down now. So you would realize that you would have graphs where a is positive, but then when you look at your graph, the thing is, both of your hyperbola seems to be on the first quadrant, even though the other hyperbola touches the other quadrants as well, and this will just be influenced by the shifts in it. Yeah, let me see from parabola lessons. What did he okay, what did P do? Okay, so remember from parabola, what did P do actually from parabola? Let's think about it. What did P do? Oh, what did we know P to be responsible for? Hmm? Yeah, so not sure if you remember very well, but P, I did say it. I did say it before I read this. P is responsible for the horizontal shift, the shift of going to the left or going to the right, right? So horizontal shift, that is P. Ne? That is P. And to answer this question as well, what do we think P is going to do in grade 11 for hyperbola? It's still going to be the what? It's still going to be the horizontal shift. But not only that, right? Not only that, it will also be a what? A vertical asymptote. Asymptote. Yeah, it will also be a vertical asymptote. Ne? And and the thing now is like, I want you to look at this, ne? I want you to look at this. Here, Q is what? It's a vertical shift, but the horizontal asymptote. We go here. What about P? P, it is a vertical shift. No, it's a vertical asymptote, but the horizontal shift. Ne? Do you see that? There is a little bit of, yeah, I forgot the word, but yeah, do take note of that. And now the other question will be, what do we mean by vertical asymptote? I will just throw something quick here. You have this, and so assume that this is your Cartesian plane, right? And as this is your Cartesian plane, you're gonna have a straight dotted line going down here. Say we have another one like this right here, right? So with this, you have your what? Right here, this is horizontal, so this is horizontal, horizontal asymptote, and this is the vertical one, right? You realize this one is the y value and this one is the x value. And remember, like I said, Q is the y value. That is why Q is the horizontal asymptote. And I said P is the x value. That is why P here, it still is the vertical asymptote, which is the x value. So if I happen to draw my hyperbola here, I would possibly have a hyperbola looking like this, and possibly one looking like this as well. As you can see, this hyperbola, it goes on it's there on the second quadrant, and it's also there on the fourth quadrant, and there seems to be nothing of it there in the third quadrant. This is what I meant to say, that it's not always like that you'd find your parabolas being on the third and the first quadrant, and so forth and so forth. With the introduction of P, things changes, right? Your parabola, the shapes, the hyperbola. I'm noticing that I've been saying parabola when I meant to say hyperbola. So forgive me, ne? For this video, just remember we are talking about what? We are talking about hyperbolas. So yeah, I noticed quite often I was making such silly mistake where I said hyperbola, no, where I said parabola instead of hyperbola. So yeah, let's go on. I think that is what I wanted to share on this side of the page. Let's see what we have on the next one, right? Yes, so Yeah. So now this is the form that we saw in the previous slide or in the previous page. We had Q. Both is the what? Is the Y value? Yes. When you see Q, we see a Y value, but that Y value is responsible for what? For vertical shift, and it is also what? A horizontal asymptote, right? And then for P, we did say, what is P? P is the um, P is the X value, and it is responsible for the horizontal shift, and it is the vertical asymptote, right? Yes. So what's important right now for us, we're going to talk about the domain and the range, né? So what is important right now is to know that Q is a Y value. Yes, it is the vertical shift, it is the horizontal asymptote, and yes, P is the P is the X value, and no, yes, P is the, I'm trying to think, is the horizontal shift and the vertical asymptote. But what's more important for now, it's that P is the X value. Now, and the same thing, remember how we treated P for parabola. When we saw P like being positive, if we write it down, we wrote a negative value. The same thing we can apply here, ne? So yeah, let's go on. So I'm not sure, right? I'm not sure if I did do justice, by giving the definition of what a domain is or what the range is, ne? But for a domain is defined as a set of x values that are defined, right? Yeah. So set of this one will be a set of x values, that are defined, in your function, in your function, all right. And then as for range, the range, it have the same meaning, but it is y values defined in your functions, uh and by x values or y values being defined in your functions, we just mean that these x values or these y values, they are there, they do exist within your, what is this, within your set of possible numbers in your functions. No. Yeah, so now let's go. The thing now is, when you look at hyperbola, because we have now two asymptotes, ne? Yes, we have two asymptotes, vertical asymptote and horizontal asymptote. And remember, by definition of an asymptote is a value that will never be touched. Oh no, asymptote is a line, right? It is a line that will never be touched or even crossed. It can be approached, yes, but it will never be touched or be crossed. So it means, solo if an asymptote exists, that value that represents that line is not in our function. We cannot find it anywhere in our function. So it's like, what I'm saying is, if you put that value on your function, you're gonna get an error, a math error, and we're gonna prove it, ne? We're gonna prove it. So for the domain is a set of x values, and the x values, most importantly, we are looking for P, right? We look at P and we're gonna say the domain x is not equals to -1, right? Yeah, x is not equals to -1. So, or maybe when you now, like, you can say x is an element of what, from -infinity to -1, but we don't include -1, ne? And then you say a union from where, from -1 to +infinity, right? -1, we do not include it, that's why we have those curved brackets, ne? And that will be our domain, ne? That will be our domain. And as for the range, we look at what? As for the range, we look at the Q, which is the y value representing the horizontal asymptote. That asymptote will never be touched or crossed, right? So that value doesn't exist. Yeah. So now we will say y is not equals to what? y is not equals to 2, or we could say y is an element of numbers from negative infinity to 2, we don't include it, a union from 2 to positive infinity, right? And now you are done. So I'm gonna show you something, guys. I'm gonna show you something for the domain. We said that x cannot be -1, and this is why. If I do say 2, let me go for it. If I do say 2 all over -1 plus 1 plus 2, it doesn't matter, because this thing right here, it gives me what? It gives me 0. Anything divided by 0, math error, right? Not a real number, so this does not exist, right? And yeah, perhaps let me show you for 2. Let me show you for 2. So for 2, I'm gonna write this as y is equals to 2 all over x plus 1 and plus 2. So I'm gonna try to write this function where x is the subject of the formula. I try firstly by transposing 2. I have 2 over x plus 1, and now say I multiply the whole thing by x plus 1. So I'm gonna have x plus 1, I'm gonna have y minus 2, I'm gonna have 2. Now I divide by y both sides. X plus 1 is equals to 2 divided by y, yes, and then I transpose, so now I have x to y minus 2 minus 1, right? So here is the most important thing. What did we say for our range? We said y cannot be equals to 2, and we see here, if y equals to 2, we're gonna have 2 all over minus, no, all over 2 minus 2 minus 1, and right here we are getting a 0, which gives us math error whatsoever. Right? So with this in mind, now you don't need to do all this calculation. I just wanted to show you why we use asymptotes for domains and the range with hyperbolas, and this is just the logic behind it. So very simply, so without any hard thinking, right, we can answer the second question and say the domain for this one, it's gonna be what? We'll say x will not be equals to 1, so we'll say x is an element from 1, and then you have your union 1 union 1 to positive infinity, right? And then as for range, use a different color. As for range, you would say y is not equals to -3. Let me erase this. Y is not equals to -3, or you could say y negative infinity -3, right? Union -3 positive infinity, and you are done. This is you have defined your range and your domain, right? Cool stuff. So now let's talk about intercepts. X, we have y-intercept, for we know x-intercept y equals to 0, y-intercept x equals to 0. So okay, so here we're dealing with x-intercept, that means y equals to 0. So we go to this function of ours, we say 0 where we see y, and then 2x plus 1 plus 2. Now we're trying to write x as the subject of the formula, so we're gonna have -2 x plus 1 and this, right? There's this quick, right? Let me just draw this line. There's this quick trick when you're dealing with fractions now. And then you have something like this, you have a whole number and you have right? You can just switch this denominator with the whole number here. So you can have x plus 1 is equals to 2 over minus 2 plus 1. Then you have x plus 1 equals to minus 1. Then you have x equals to minus 1 minus 1. Then x equals to minus 2, right? But just to show you that I'm telling the truth and you can safely use this trick, I will do it the way, you know, we kind of used to. So yeah, so let's multiply by x plus 1. We're multiplying everything by x plus 1. X plus 1. So when we do that, we're gonna have minus 2 into x plus 1. We're gonna have 2, right? Then we divide by 2 both sides. We're gonna have x plus 1 equals to 2 divided by minus 2. Then you're gonna have x is equals to minus 1 minus 1. Then x equals to minus 2, just like we had, right? So you see we still end up in the same answer. So yeah, you can safely use that trick, man. Yeah, it's like if you have a equals to b over c and you're trying to find c, you can just say c equals to b over a, and that's basically what I did. So now the x-intercept is what? It's minus 2 and 0, right? We are done. Let's go for the y-axis. X equals to 0, né? So with x equals to 0, where we see x, we put 0. So we have 2, 0 plus 1 plus 2. We have 2 plus 2. We have 4. And therefore, we have 0 and 4 as our y-intercept, right? And about asymptotes, I've already spoken about them. For example, your vertical asymptote on this equation, this one, right? Your vertical asymptote there, it's gonna be what? Remember it this way, né? The q is responsible for the vertical shift, but the q is the horizontal asymptote. You see, so the p is responsible for the horizontal shift, but it is the vertical asymptote. So the vertical asymptote, it's gonna be what? X equals to minus 1, which is p, and the horizontal asymptote is gonna be what? It's gonna be y equals to 2, which is what? Which is our q, right? Yeah, sometimes you get questions just asking you what is our vertical and our horizontal asymptote in this, and then you'll have to give answers such as these. Yeah, so let's move on. Let us move on. Let me see how far I am. Close to being done. So yeah, this might rather be a short video. Good. Axis of symmetry. Nice work. So remember, we spoke about axis of symmetry when we were dealing with parabolas, and we said that axis of symmetry, those are lines, that divides our graph into two identical parts, sides. Yeah, right. And back in grade 10 last year, back in grade 10, what we used to do is that, or maybe not what we used to do, I'm not sure. I think we didn't talk about it much. We didn't even talk about it, I think. Maybe we did. But our axis of symmetry in grade 10 were just these two equations, right? Both of them, these were our axis of symmetry. Now with the introduction of p and q, right? With the introduction of p and q, I mean, yeah, q has always been there, so I can just say with the introduction of p, there's our equations of symmetry. Yeah. If you look here, we still have that positive gradient y equals to x, and there it is. We still have y equals to minus x, there it is, and this is the constant number 1 and constant number 2. constant number 1 and constant number 2. Right, so yeah, let's try to find our equations of symmetry now. And maybe before, let me illustrate something. If I were to draw this graph, I can say I have my Cartesian plane, right? There's my Cartesian plane right there, and then I have y equals to 2. This is y equals to 2, right? And I have x minus 1. This is x minus 1, right? Y equals to, what am I doing? 2, x equals to minus 1. This is y-axis, go for black pen, y-axis, x-axis, and then this right here is the horizontal asymptote, and this right here is the vertical asymptote. Right, so these lines, these two lines, these two lines, right? Let me just say line number 1 and line number 2. These two lines, both of them, they're gonna intersect here, right? They're gonna intersect here, and it's gonna be something like this. It's gonna be something like this: one with a positive gradient, and there will be one with a negative gradient. No, exactly. So this is how our lines are gonna look like. There's one, this one, negative gradient, negative m, right? And this one will have a positive positive m, which is positive gradient. So basically we're going to use these points to find our constants. So let's start. Let me go for red. So you say y equals to x plus c1, which is, and then you substitute your the points that you have. Remember those points, this point right here where they intersect, that point is minus 1 and 2. So you go, this is 2 minus 1 plus c1 transpose 2 plus 1 equals to 3 equals to c1, and therefore y1 equals to x plus 3. Right, that means right here this is 3. Exactly. And then different color. Now for the second one, you would say y equals to negative x plus c2. Right, substitute the same point, that is 2 equals to minus into minus 1 plus c2, then minus the minus, that's positive, so you have 2 minus 1 c2, you have c2 being equals to 1, and therefore you have y2 equals to minus x plus 1, right? Saying that the point here is what? Is 1. It makes sense even graphically. We can see our y-axis where x values are equals to 0, right? And graphically it even makes sense. So this is just how you find your axis of symmetry. This is axis of symmetry number 2. This is axis of symmetry number 1. Pause the video and try to find your axis of symmetry for this one. I'll get started. First and first, I know, right? So also this thing, if it helps you to draw it graphically, I would say draw your asymptote graphically, because for some people it does really help them visualize this thing, but then also, like, if you are able to, you would see that, okay, the intersection is minus p and q, and that point, in this case, that point is what? It's 1 and minus 3. So this is our intersection, so we're gonna use this point to find our p's. So let's say y1 equals to x plus c1. You substitute your values, minus 3 equals to 1 plus c, and then minus 3 minus 1 equals to c1, minus 4 equals to c1. Therefore you have y equals to x minus 4, right? That's the first one. Now the second one, you'd say y equals to minus x plus c. Remember, negative gradient, positive gradient, right? So yeah, we substitute our values. Minus 3, 1 or minus 1, c. So now it's minus 3 plus 1 c. Let me say c2, and then c2 is equals to minus 2, and therefore you have y is equals to minus x plus no minus 2. Then you are done. This is your first axis of symmetry, your second axis of symmetry. Sometimes these people, they will say calculate or give us the axis of symmetry with a positive gradient. Then when your focus is just here, we have a 1 with a positive gradient, and therefore this is going to be your answer. But if they say axis of symmetry with a negative asymptote, you know where to go to. So yeah. Yeah, that's it with the axis of symmetry. Let's see what we have next. Let's see what we have next. So yeah, this will be the last part of the video. So yeah, parabola was just a lot, man, compared to hyperbola, it seems. Yeah, and I still feel like there is something that I left there with the parabola, but I will get to it. Sure. Let's now sketch both of these hyperbolas. So with everything that we have learned, now the question is, how do we plot these parabolas? Look at me again. I'm saying parabola. I want to say hyperbola. I can't wait to go to exponential functions, so that I can stop with this parabola. Yeah. So with this one, this is my advice, This is my advice. I'm gonna write this down and erase them for space when we start writing, This is just my advice. When you try to sketch a hyperbola, first draw your asymptotes. Yeah, I keep missing that P. Draw down your asymptotes. Then I would say find your intercepts. Both of them, x-intercept and y-intercept. Find both of them. Then let me see what's more important. You have your asymptote, you drew them, and then you have your x. Yeah, you have your intercept, you drew them, and I think maybe an actual point or coordinate, and then you'll be fine. So let us use all these points to draw our hyperbola. Right, what do I have there? I have my y-axis, x-axis. Let me do the arrows. Right, so now what do we have? Number one, draw your asymptotes. So let's look. The easiest one is the q, because I would say this right here is my horizontal asymptote, which is this. Now my vertical asymptote, which is -1, is gonna be right here. Oh yes, right. So I can say x equals to -1, y equals to 2. Yeah, so I have drew up my asymptotes. Now I have to find my x-intercept and my y-intercept. I mean, we did do this problem. Let me go back. Where did we find those things? So yeah, we used this. I found my x-intercept was -2 and 0, and my y-intercept was 0 and 4, right? So I would say x-intercept, that's -2 and 0, and then y-intercept, that's 0 and 4 for this one. Yeah. So let's plot them up. This is right here, this is -2 and 0, and then where is 0 and 4? 0 and 4, so it's gonna be here. This is 0 and 4. Yeah. So now I find an extra point. I have both my intercept. I can find myself an extra point. So the question is, where would I like that extra point to be? So that, my dear, is just your own decision, your own choice. Basically, as to where the value will be. I'll just make, maybe say I'll find two other extra points, two extra extra points, right? Yeah, cool. So I want to find some point over here, so I will go here. Let me yeah, that's so I have two, I have alpha x plus 1 plus 2. Nah. So this is what my hyperbola looks like. I'm gonna try to find some x values, no, some y values. Say for example, I substitute the value minus 6. So if I get -6, -6 is somewhere here, that's where I have -6. I'm getting the value 1.6. So I could say I have the value somewhere there, right? And then I, yeah, straight arrow, yeah, and that's my extra point right there. This value, remember, the value here is what? The value here is -6 and 1 over, no, 1.6. Let me just say 8/5, makes it easier. That's the value there, né? And then I can go that side, maybe find, say maybe x is minus, since my x cannot be -1, or maybe let me choose a positive x value. Let me just say 5. Now if x is equals to 5, I'm getting 2.333, right? So maybe say 5 is somewhere here, and that means this somewhere here is gonna be my value, and then I'm gonna have something like this. Yeah. Oh damn, it touched mine, just touched the asymptote. It should not. Yeah, and this point over here, it's 5 and 7/3. Right, so that's what I'm saying. I think the most important part is you have your asymptotes, and you have your x and y intercept, and you have an extra point. That's what most important. And it doesn't matter, you can have your extra point on this side, or you can have it this side, or you can have it this side, or this side. It's all up to you, ne? Just remember that it's all up to you. And basically you are done with this. Then you can just say maybe this is g of x, then you are done. You're gonna get 100 on this. So then I'll say post the video and try to sketch this graph. This graph, to sketch it, the first thing, before you even go to your calculator, you're like, okay, I'm gonna draw up my asymptotes. I have a positive 1, so I'm gonna have this, and I have a negative 3. Right, this is x is equals to 1, this is y equals to minus 3, and this is y-axis, this is x-axis. So also now there's something I didn't mention. So like my a here, it was positive, so I knew that my graph was gonna look something like this, right? They were gonna look something like this, and yeah. And also I don't know, I mean, it's just up to you, this one. Maybe, I don't know, just talk to your teachers, guys, just to find out, but I don't think it's necessary. You can also, put your axis of symmetry right here, but it's I don't think it's really important that you do, but I mean, maybe just being desperate and looking for more marks, you can just do it. This will be the positive gradient 1, and this will be the negative gradient 1. Now you can just put on your axis of symmetry on your graph, and you would see they intersect right at the point we agreed they would both intercept at. So yeah, but yeah, we were here, we were here. Let's work on this, gentlemen. We have our asymptotes. Now we find our x-intercept. Y-intercept is quite easy. Y-intercept, y-int, x equals 0. So you have y minus 4, 0 minus 1, minus 3. Then you have 4 minus 3, you have 1. Therefore you have 0 and 1. And then for x-intercept, it's a bit challenging. Y equals to 0, so you have 0. Let me just say plus 3, minus 4, minus all over x minus 1. Then remember that rule, I can remove this 0. Remember that rule, right? We can just switch x minus 1 with 4 over 3, and then we go x equals to minus 4 over 3 plus 1. So we go to a calculator, 1 minus 4 over 3. That is, the answer then becomes, minus 1 over 3. So therefore x-intercept is minus 1 over 3 and 0, right? Yeah, and now we can plot them. We can plot them. So starting with the y-intercept, it's 0 and 1, which is gonna be here. This is the y-intercept, 0 and 1. Yeah, and the x-intercept, which is 0, which is minus 1 over 3, it's gonna be somewhere here. It's gonna be somewhere here. No, somewhere here. No. So now when we plot our thing, you can also maybe have an extra point. That extra point, say maybe, so I'm gonna put in this. I have minus 4. Let's say x equals to 5. So then I have 5 minus 1, minus 3. So if I put minus 5, no, if I put 5, say this is 5 right here, I'm getting minus 4. So say this is minus 4. So then I'm gonna have a point over here. Yep. So in that case, I'm gonna have something of this nature, of course, going down like this, and then I'm gonna have something of this nature on this end. And the reason why the parabola is shaped like this is because our a is negative, right? So yeah, we have both of our intercept right here. We have that extra point. You have your axis of, you have your asymptotes, and I mean, you can just quickly calculate your axis of symmetry. Like I was saying, this is something I kind of do have to confirm. I doubt it's necessary. But yeah, just for safety, put it there. Yeah, I wanna for those extra marks. There's one positive and there's one negative as well. So yeah, then you're done. Then you're done plotting your thing, plotting your hyperbola, and yeah, this is the end of hyperbola. Yeah, we are done. So in that case, I'll say guys, thank you so much, all the best, and I will see you in the next video where we will be talking about exponential functions. Bye.